Okay, so we're starting the database session. In this session, we are going to cover very basics. We'll touch upon all the topics in database and we'll cover the very basic details about those topics. The finer details we'll see in subsequent session. So first and the very basic thing about database is database indexes. So and a lot of people get confused with the indexes. So as we always do, before we start any topic, we are going to talk about we are going to pick up a real life scenario. We are going to talk about the scenario, and from that scenario, we will try to come to technical solution. Right? So, what is the first time you had heard about indexes? They were, in which context? I'm not talking about technical context, non-technical context. What was the first time you heard about database indexes? Not database, but the indexes in general. I mean, that's a technical, but normally we talk about indexes in the book also, right? Like we say in book, we say that we always look at the page numbers, right, as a first thing. So the question that we should ask to ourselves is why book has indexes. What is the advantage of that page number index? So forget the technical details. Let's talk about general. In general, just about a book. So you have a book. Book has the page number, and page number is an index. So index is a very simple term, very simple topic. So why a book has page numbers? What advantages do you get from that page number index? Any advantage that you get? What kind of advantage do you get when you get a page number on a book? The index with the page number. Okay, it will be easy to get to a page right away. Just remember whatever answers you are giving because we are going to later correlate to technical details. So with the indexes on a book, the page number index on a book, it is easy for you to search a particular page, right? So you have this indexes. Now I'm going to give you a, we are going to discuss a real life problem. So you have this book. I come to your house and I tell you that in this book, so this is a historical book. In this book, there are many pages which has year details. So there are year details like year 1984 something had happened, year 1985 something had happened. So a lot of pages has this detail, right? Now I'm gonna come to you tomorrow and I'm gonna ask you all the page numbers where year is mentioned. I want to have all the page numbers where year is mentioned, right, in this book. And I'm gonna come tomorrow and ask you that detail. So you already know that I'm gonna come tomorrow and ask you this detail. So will you, so what will you do today? Will you do something today? Okay, what will you do? Mhm. Okay, index page right now does not have it because index page just have the page number. So it does not have the year information. Okay. Okay, say it is not there in at the end of the book also because the end of the book will not have all the details. I want to have all the page numbers. Okay. You have to search page. Very nice. So you will search page by page and you will list down something, right? So you will go page by page in your book and you will list down something like this. You will say here, maybe you will say 1984. So you might go like this. Maybe page number one, year 1984 and 1985 is mentioned. Then you will say page 10, year 1995 is mentioned, and you will keep doing this, right, on every page. So page number 1, then maybe page number 10, maybe page number 12, 15, 18, 20. You will keep doing things, right, like that. Correct? Okay. What advantage are you getting when you do this today? So why are you doing it today? I'm gonna come and ask you the data tomorrow. So why were you doing it today? Yeah. So it will be perfect. So it will be faster for you to give me the data tomorrow when I'm asking you the data. So if you have done that preparation today, you can give me the answer faster tomorrow. If not, then when I come to your gate tomorrow, then you will ask me to wait, and then you will be searching the whole book, and then I'll be just waiting for your answer. Correct? Okay. So now we take this to bit of technology. Assume that the book that you were referring to is a database. Right? So database for me is anything that contain any kind of information, any kind of data. So assume that this whole book is a database. Okay, and you are somebody through which I connect to database. So you manage how database perform, and I am an application, right? So I am an application, and I am coming and asking some data from you. When you know in prehand, when you know prehand that some application is going to come tomorrow and ask for certain data, then you do some preparation today, right? Okay. Now let's take this problem to the next level. So you have already created, so there was one index present, which was the page number. So you have created another index now. So page number and year. So now you have mapped page number and year. So this is another index that you have created, correct? Okay. Now I'm gonna give you a scenario. Say that I come to you and I say to you that the book that you are having, by mistake, one page was not there in the book. That was removed from the book somehow, right? And now, so page numbers were already printed. So the book was printed with all the page numbers in sequence. But by mistake, when we were printing, we forgot to print one page. Now I'm giving you that page and I'm asking you that put this page after page number 20. So the new page that I am giving to you is it this is page number 21, right? So what will you do? Just from the book perspective, I'm giving you a new page, page number 21. What will you do normally? Don't worry about technology. What will you do normally? Uh-huh. Okay. Now if you put at the last, then how will somebody read that page? They will get to know about this page at the end. So you have to stick it after page number 20, and there is a provision. So you will stick it after page number 20, right? Will you do anything for your page number index, the initial index? Will you have to do something on that? If you stick it after, if you stick it after 20, then your this new page becomes page number 21, and then your old page 21 becomes 22, because the no, the book was already printed. Everything was printed in sequence. Everything was printed in sequence. So there was page number 20, 21, 22. Everything was printed in sequence. So I'm giving you now page number 21 and saying that by mistake this page was not printed. I'm giving you this new page. So you stick it after page number 20. Now this page becomes 21, and the page number 21 that was already there becomes 22, 22 becomes 23, and henceforth. Correct? So all the page numbers, they get new page number, right? Will you, what happens to your index, the page number index? Will you have to go and change that also? Sure. The page number, the page number index, the initial index, the page number index, will you have to change something in the page number index? All the index. Okay. Screen sharing, you're saying? Screen sharing is fine. It's fine. Okay, I will say pause and then I'll say resume. We'll see. Okay, we'll come to screen sharing. Let's not worry about it for now. So you will update the indexes on the initial page also, because all the chapter numbers, it will say chapter number 1 from page number 1 to 20, chapter number 2 from 21 to 40. So all those will also have to be updated because now page numbers are shifting, right? What happens to your another index that you had defined? So you had defined another index about this year. Will this change? So there was another index that you had defined about the year, right? About the year. Will this also change? So here, if say that, so it will change. Maybe after page number 21, the index will change, right? But index will change. So this will also change. The year index will also change. Because say that you had written page number 23 has year 1985, but now that 23 has become 24. So rather than saying 23, you will say page number 24 has this year. So you will also have to change this index, year index, correct? So when I am giving you a new page, your time to complete this whole process is dependent on what? When I'm giving you a new page, your time, total time taken by you to complete this whole process is taking a new page, updating the indexes, depends on what? What will change the amount of time taken by you? Exactly. Yeah. So changing the indexes will determine how long you take to stick the new page. You take to stick the new page and do everything, because sticking a new page is not just sticking a new page, it's sticking a new page and updating everything in the book and indexes, right? So it will depend on how long you take to update the indexes on the book, correct? So right now you have just two indexes. One is page number, second is year. Say that you had five more other indexes. So rather than year, now I am asking you that give me all the pages where some city name is mentioned. So what you will do is you will create another index with the city name, page number and city name today, correct? Similarly, if I ask you that give me all the pages where some countries mentioned, so you will go and again create another page index which will say that page countries mentioned on page number XYZ, right? So when I give you a new page, amount of time taken by you to stick that new page depends on how many indexes you have. Do you agree? Agree? So amount of time taken by you to stick a new page and update all the information. All the information here is indexes. Update all the index information will depend on how many indexes you have created on the book. Yes? Okay, fine. Now I'm giving you another scenario where I am telling you that, oh, book is there, but book number, page number 25, it has by mistake come from another book. So this page number does not belong to this book and I want to remove this page from the book. So I want to delete that page from the book. So what will you do? So you will go and remove the page. As soon as you remove the page, your page number 25 is gone. So your page number 26 now becomes page number 25. Okay. No, I mean the book was already created with page number 1 to 2 to 23, 24, 25, 26, 27. Yeah, it was there. It was there as if it was part of the book. Now I'm saying the page is. So you will again remove the book and you will again go and update all the indexes. So again amount taken for the deletion of the record will depend on how many indexes you have. Correct? Okay. Okay. But if you create many indexes, what will reduce? Which operation will have minimum time? Which operation? So indexes will help you doing what? Which operation faster? Perfect. So your search will be faster if you have more indexes. Because if I come to you and tell you, give me all the pages where country is there. So you already have the index. You will just go to those page numbers and tell me that those are the page numbers, right? And I can read those page numbers and go home because I wanted to read the pages where some kind of country is mentioned. So I'll come to you, I'll tell you, give me all the pages where country is mentioned. You already have the data, you will take the data, you will tell me go to page number 1, then go to page number 10, go to page number 15. I'll read all the pages and I'll go home. So whole operation, the whole interaction between you and me is faster now. Correct? So I am an application and coming to you and asking different things from you. Okay, let's now take this example to technology and it will become very simple. All the answers that you have given, now same answer will be applied to technology. So assume the database was a book. Okay, so your book is a database. Each page number is a row in the database. Each page number is a row in the database. And now we are going to ask the same questions again. Okay, so say that you have a database and now each page is a row. If you have more indexes and if I insert a new record in the database table, a new row in the database table, the amount of time taken for the insert query or amount of time taken to insert that record or amount of time taken to stick that page will depend on what? Amount of time taken to stick the page depends on number of indexes you have. The more number of indexes you have, the more time you will take to insert a new record. If I run a delete query on the table and if I try to delete a row from the database table, from the same table, the amount of time taken by me to delete a particular record, amount of time taken by me to delete a particular page from the book will depend on what? Again the indexes, right? So in a database table, the more indexes you have, the more time it any query will take to insert or delete a new record. Okay, as simple as that. But the amount of time taken by a search query, by a select query, so search is a select, right? So by a select query will be less if that query uses the index, right? If I ask you to give me all the pages where country is defined, so you had already that data available. If I suddenly come and tell you to give me all the pages where continents are defined, then you did not have any index, you did not have the data, then you will have to tell me, okay, please wait, I will have to go and search the whole database. Then in that case, you will go and search the whole database and give me the data, right? Okay. So it's very simple concept, right? And it is asked in a lot of interviews. So that what is the use of index? Why should I not define too many indexes in my table? Because indexes are helping me in searching the data. So answer is yes, indexes will help you search the data faster, but your insert query and your delete query will now take longer. Because when you delete a record, when you insert a new record, your indexes have to be updated. The more indexes you have, the more time it will take to update the indexes, hence it will take more time for insert or delete operation. Clear? So very basic concept about indexes, how many indexes you should have, why you should not have too many indexes is clear. Okay, now I'm coming to clustered and non-clustered index. So there was one index which was the page number index, right? So page number was also telling you the actual sequence of the data storage, actual sequence of the pages. So page number 2 will always be after page number 1, page number 3 will always be after page number 2. It is the actual storage of the data. It is the actual storage of the pages. It is the actual order in which pages are there in the book. It is the actual order, right? While the second index, where you were finding all the pages where some year was mentioned, so first there was page number 1, then page number 10, then page number 15. Is this the actual storage of the data? Is it the actual ordering of the storage of the data? Page number 1, then 10, then 15. Does page number 10 come after page number 1? Just after page number 1? No. So page number 1, then page number 2, then 3, and then page number 10 after page number 9, right? So second index that you have defined about the year or the country or the continent, that is not representing the actual storage of the data. It is representing some kind of logical storage, but it is not the actual storage. Actual storage is page number 1, then page number 2, then page number 3, then page number 4. That is the actual storage of the data. But page number 1, then page number 10, then page number 15, it is not the actual storage of the data, but it is a logical storage of the data that you have brought in. Right? So the first type of index is called as clustered index. Index which represents the actual storage of the data. So in the example of the book, which index is the cluster index? Which out of the three indexes that you had created, two you had created, one was already there. Which index is a cluster index? Which index represents the actual storage of the data? The very first index, the first index which was containing chapter and page number, the initial index which was already present with the book, right? Because that represents the actual storage of the data. It is telling you that chapter number 1 is from page number 1 to 10. So page number 1, then page number 2, then page number 3, then page number 4. It is the actual storage of the data. So this is called as cluster index. The other indexes that you had defined, they represent some kind of logical data, but they are not the actual storage of the data. It is not that page number is 1, then page number 10, then page number 15. Right? Such indexes which does not represent the actual storage of the data, they are called as non-clustered index. Okay. So cluster index is actual storage of the data. So now next question would be, how many clustered index can you have in a database table? I'll ask you the question on the book, then you will get this answer. In how many ways can you stick the pages of the book? In how many ways can you stick the pages in the book to represent their correct sequence or to represent their actual storage of the pages? In how many ways? Only one way, exactly. There's no other way, because page number 1, then only page number 2, then page number 3. There's no other way. There's only one possible way of storing the data, right? So the interview question is, how many cluster index can you have? The answer will be only one. In database table, you can have only one cluster index, because cluster index is representing the actual storage of the data, and data is already stored. So there is only one way I can store the data. How it should be stored, that could have been defined by database algorithm, but once it is stored, it is there, and it is only one way that you can represent. Okay, so which page should come before which page? So maybe you would have thought that I would put chapter number 8 before chapter number 5. Then maybe chapter number 8 is already renamed to chapter number 4. So all the decision is already being made before putting the pages in the book. Once pages are put in the book, they are representing the actual storage of the data, and there is only one way I can store the pages in a book. So the answer is, you can have only one cluster index in a database table, not more than one. Right? How many non-clustered indexes can you have in a database table? So how many? So cluster index is clear, right? Cluster index is a page number index. You can have only maximum one cluster index. about the non-cluster index. So one non-cluster index was about the year, second was about the city, then third was about the country, fourth was about continent. Can I have more than one non-cluster index? So non so we already had more than one non-cluster index. So you can have more than one non-cluster index. I think database says that maximum you can have 255 non-cluster index, but I'll have to verify the data. But I think maximum they allow is 255. But if you just normally think, then you can have as many non-cluster indexes as you want, depending on your data. You can create as many as you want. Right? Depends on the requirement. So I am an application and I am coming to you. So you are a database. I am coming to you and I am asking you to give me all the pages where continent is there. If you already know that I am gonna come tomorrow and ask you this data, then you will create index today. If you don't know what I am gonna ask tomorrow, then you cannot create index for that. If you know in advance, so that is why when we define non-cluster index, the application person who is building the application and the person who is creating the database, they have to talk to each other. And the queries that we use frequently in our application, right, they become non-cluster index in a database table. So when I was telling you that give me all the pages where year 1984 is defined, so year is now kind of becoming a column in the database row. So say that you have a database with 100 rows, right? Similar to your book with 100 pages. Now I had told you to give me all the pages where year 1984 is defined, correct? Okay. Similarly, if I go to database table and if I tell you give me all the rows where year 1984 is defined, it means year is becoming a column for us. So you will go and look at the column value at all the rows. So where your column and row will intersect, you will say this is the row where year 1984 is present. So we look at the application, we look at, so when we say column, it means it is going to become one of the clause in the where clause, right? Like select star from book where year equals to 1984. And all the rows which are written, these are the page numbers of the rows from the database table. So always remember in your mind that the pages in a book, they are the rows in the database table and the whole book is the database itself. Okay, so index is very simple. We have understood clustered and non-clustered index. You can have maximum one cluster index. Theoretically, you can have as many non-clustered indexes as you want. You will have more than one non-clustered index. Which column should be used to define non-cluster index will depend on which columns are used by the application query frequently. So non-cluster indexes we keep redefining. So if we know in advance that application is going to ask about year and country and city, then I'm gonna make a non-cluster index for them. Right? But if I don't know today and then application tells me tomorrow, then I'll go and define non-cluster index again. So now there are cases where they say that my query is performing slow. You might have heard about it, that people say my query is performing slow, what should I do? So when some query is performing slow, one of the first thing that you should look at, that is it a select query or is it an insert query or delete query? In both the cases, you have to go and look at your indexes. So if a select query is performing slow, it means the search operation is performing slow. So what can be a problem? If a search, so I'm asking you what can be the problem? If a search query is performing slow, it is taking so much of time to search the pages, right? Why is it taking so much time to search the pages? Because you had not created the index in advance. That is why each time when I am coming to you and asking you the data, each time you are searching the book. So say that you had not created an index for year. Say that you had not done it. So I had told you already that I am gonna come tomorrow and ask you the year, all the pages where year is defined. So you did nothing today. You were just sitting there and did nothing. When I come to you tomorrow, what you will say is, I am an application, you are database. So what you will say is, okay, application, you have to wait. Let me go and search all the pages in the book and then I'll tell you the answer. Right? So you will search all the pages and you will give me the answer. So I am waiting and now you are searching. Obviously this search query is going to take longer. So the search interaction between you and me is going to take longer. Somehow I got the data, I went back. After one day, after some time, I am again asking the same data. Since you had not created index, you will again go and search the database, whole book. You will again search the whole, you will again say, okay, application, wait, let me search the whole book. You will again search the whole book and give me the data back. So again, I am waiting. So each time I am asking you this data, each time application is searching for some data, the whole operation is taking longer. Yes. So what will you do now? Now we are programmer. Now we are analyzing why it is taking longer. So somebody is telling that each time application is coming to you and asking the data, each time you are searching the whole book, that is why it is taking longer. So what is the solution? The solution is very simple. You know that what data application is asking for. So application is saying where year equals to 1984. Why don't you go and search the whole book in advance, right, and keep an index? It means to make a search query faster, you have to define a new index. You might have to define a new index. Yeah. So what you will do is you will go and create a new index. When you are creating a new index in a database table, it is as good as you going to each page in a book and writing that page year 1984 is present in page number 1, then page number 10, then page number 15. So now you have done this. You have put this fix. Now I again come to you and I say, okay, give me all the pages where 1984 is there. So now you will say, oh, I already have the index present. I know that page number 1, then page number 10, and page number 15. Only 3 pages has year equals to 1984. So when I ask you the data, you will say, okay, I don't have to wait. Page number 1, go to page number 1, then go to page number 10, and go to page number 15. And the interaction between you and me will be shorter now. So it means my search query has become faster now. Yeah. But if I try to insert a new record in the database table now, then apart from the page number index, I will have to update this year index also. So my insert query will be slower and my delete query will be slower. And so insert and delete will become slower as you increase the number of indexes. Your search query will become faster as you increase the number of indexes. So that is why you cannot go to extreme on any cases. You cannot go and define index on all possible column combination, because then your insert and delete is going to become slower. Which table in your application do you think will be the best suited tables where you can define more number of indexes? What do you think? Now that's a question, that in your application, which kind of tables do you think you should go and define more indexes, and which tables you should not define too many indexes? No, I mean table is not clustered or non-clustered. It is an index that you make, right? So my question is, in database, in your application, there are two kind of tables that we normally define from business perspective. One will be your transactional table, where your transaction data goes, right? Like in a banking application, when you are taking amount money from your ATM and you are putting money in the bank, then there will be one table which will be maintaining your transaction, right? That you have taken out 200 rupees, you have put in 500 rupees. So such tables are called as transaction table, where rows are frequently added or deleted. These are transaction tables. Yes. So if rows are frequently added and deleted, would you like to have too many indexes in such table? No, because each time insert or delete will become slower. So you would not want too many indexes in such table, because you know that this table is used for a lot of transactional data. But there are tables in your application which contains the metadata information. Metadata. Whenever application starts, those tables are read, but they are never deleted or inserted. Nothing is inserted in them or deleted. Such tables are called as metadata table. Right? They are kind of static tables. They hold static data. If you know that there are tables where records are not going to be inserted or deleted frequently, then in such table, the operation that you will be doing will be search operation, maximum search operation. So if you are doing only search operation on a table, then you can go and define more indexes, because indexes are going to increase the efficiency of the search. Right? So in such tables, so answer will be in metadata table, you can define more indexes, because metadata table will have, you normally do search operation on metadata table. Okay, so this is the maximum questions that will be asked in interview around indexes. So we have covered indexes. Okay, let's move forward and talk about next topic that we want to talk about will be let's talk about procedure and function. Right? So procedure and function, they are very simple concept in database. Concept wise they are very simple. Your implementation might be complex, but the concept is very simple. A procedure to me is like uh, it is like a method in Java. Whenever we write a method in Java, say that there is a method which says get customer's account number. So there is a customer, I will give you the customer ID and give me the account number of the customer. So what will you do in that method? So first you will define the method, you will give the method name. So you will say I will have a method public. Let's define this method. So you will say public int get account number. Correct? So your implementation will start from defining the method. When you say public int, it means you are defining the return type, that this is what I am going to return. I am going to return an int, and then there will be one input. Input will be customer ID. Correct? So you have defined the method name, you have defined the input, you have defined the output. And then you will put a logic here. What will be the logic? Connect to the database. Then you will fire a query. Select star from, say there is account table where cust ID is equals to whatever is the customer ID passed in. And you can also say select account number, whatever. And then you will say return. You will fire the query and then finally you will say return. A procedure or function is very much similar to this. A very simple concept, very similar to this. So whenever you are defining a procedure or function, you have to first define it. So here we are in Java, we write a method. In procedure, you will say create procedure or you will say create function. So whenever you are writing a procedure or a function, the first step will be to create it. Similarly for the method, so the first step is to define the method name, the input parameter, the output parameter. Similarly in a procedure or function, you have to say create my procedure. This is my input variable and this is what will be the output. Simple as that. Right? You will put your logic inside the procedure and you will return something. Now procedure and function, there's only one difference. So procedure may or may not return the result, but function always have to return a result. So when you have to choose between procedure and function, then you choose function when you know that this function should always return a result. Always return a result. So if you are passing a customer ID where you are sure that account number will always be found. All the customers I already know that they are in the database, account number will always be found. Then you use function and function will return you something. Procedure, when you are not sure whether for this customer ID there will be an associated account number or not. You are not sure about it. Then you can use procedure because procedure may or may not return the result. There are other things that we'll talk about when we talk about procedure and function in detail, uh, like when we write a method, we need something to loop through. We write the for loop in the method. Similarly, in procedure, there's something called as, in database term, there's something called as cursor. The cursor is used to iterate the data. We'll come to all those things in detail. But a procedure or a function is similar to a method in Java. So when I want to write a functionality in database, I will use procedure or function. If it is a normal select query, then I don't have to write a procedure. Whenever I want to do any complex logic, whenever I want to do any logic, then I will use procedure or function. Uh, there might be cases where, say you get a record from a database table, you have to iterate through the record, and so say that you have a database table of employee, right? You want to go through all the employees, pick all the employees whose salary is more than 10,000. For all those employees, you have to go to the address table, find their address. From all those addresses, you have to go to the postal code table, find their postal code. Such logic you can achieve through a complex query also. But whenever you have such logic where you think that this logic is more like a method to me, this is more like a functionality to me, then you write procedure. So whenever you think there is a logic building up, there is a business logic building up, there is a kind of method evolving, then you write a procedure or function, or else you can simply write a query. Okay, so procedure, function, let's see that one or two definition of the procedure. How do we define procedure? Okay, we'll come to this execute plan, other things. So procedure, functions and trigger, these are three similar things. Similar, exactly same, not much difference. Trigger, you might have heard about that, put a trigger in a database table. So trigger is like a procedure. So when we write a procedure, we invoke the procedure to get the data. From our program, we will say execute this procedure. So like we say execute this query, we also say execute this procedure. And when a procedure is executed, it returns us some data. May or may not, but depending on your implementation. A trigger is similar to a procedure, no difference. Trigger is same as a procedure, but it is driven by database itself based on some event. Those events are update, delete, and insert. So so if you want a functionality where if you insert any record in the employee table, another record should be inserted in employee history table. Say that you are maintaining employee history table. That what all. So say that there is a customer who is joining your bank. So you want to track where he is currently. So you want to maintain a history table also. So first record will be that customer has filled in his account number form. So you will write and you will enter all the detail of the customer and you will say submit. When you say submit, behind the scene you will fire an insert query in the customer table and all the details of the customer will be inserted in the customer table and status will be that form has been filled. At the same time, whenever you insert anything in the customer table, you want to insert another data in a customer history table so that tomorrow I can go and look about how this customer registration has gone. Right? So you want to do something on the database insert or database update or database delete, because these are the three operations through which you can modify the data in a database table: insert, update, delete. Whenever you want to do something on these three events, then you write trigger. In writing the trigger is same as writing a procedure, no difference, except that when you are defining it, you say that it is a trigger. You say that this trigger should be run when you insert a data in the table or update or delete. If you say just run this trigger when something is inserted, then it will not be run for update or delete. So you explicitly you say that I am writing this trigger whenever any record is updated, deleted or inserted in this table. You can pick up those operations in any combination. Okay, this seems to be hung. Okay, let me open this again. Okay, so today we are just covering all the basics and we'll come to each finer details from tomorrow. Yeah. So we'll look at the procedure, signature. Okay. Okay, you also have the document. Can you open it locally? If not, then I'll try to open it. Okay, process. Yeah, no, go down. In that document, everything is there. Yeah, just go to the procedure section. Okay, so how is procedure being defined? What is written there? Yeah, yeah, sure. So the header, as we had seen, the header is like what we had defined for the method. So the method, here we were saying this is the method name, input parameter, output parameter. Similarly, when you create a procedure, this section will be called as a header. This whole logic that we are writing will be the body. And then in method also we write try and catch block. So we write catch block. So that portion becomes like exception in procedure. Right? So procedure is similar to a method, no difference. Until the terminology becomes different. So the way we implement method in Java, similarly, to achieve a Java method in database, you have to write a procedure. So when we define a method in Java, whenever we want to achieve a functionality, get me the account number, get me the name, get me this detail, then we write a method. Similarly, in stored procedure, we write in stored procedure when you think there is a complex logic and your simple query might not give you the result. Okay, so okay, I'm able to share my screen now. So general syntax to create a procedure is, so we say create, don't worry about replace. So we say create procedure and then we'll say procedure name. So we will say create procedure get account number, right? Create procedure then procedure name, right? Okay. All right. So create procedure name, and then list of parameters. So this is similar to method where I was saying public int, then I was saying method name, get account number, then I was passing the customer ID, right? And then begin, uh, begin will be your body, where you will put the body. Yeah. Exception will be your catch block, like a catch block, and then you will end your procedure. So it is similar to method, nothing to worry about. Why we say create or replace is when you're defining a procedure, here you're defining the procedure. We say replace means if there is any existing procedure with the same name, then replace that procedure with this new procedure definition. That's it. So it is possible that somebody had already defined a procedure with the same name, but I don't want this procedure. I want this procedure with this name. So it will go and replace the existing procedure. Also, when you compile uh, when you compile the procedure many times, so when you're writing a procedure, like when you're writing a method, you have to make many changes. Like you'll run the procedure, you will run your method and see whether the results are coming fine. If they're not coming, then you will again change your procedure. So each time when you compile the procedure, you want this new definition to be taken by database. You don't want the old definition to run. That is why we say create or replace. So if there is any existing procedure, then replace that procedure. Okay. Okay. Function will be similar to procedure, but rather than saying create procedure, it will say create function. Right? Trigger will say create trigger. All three are same. No difference between the three. Okay, that's not going down. Okay. So we've talked about indexes, talked about procedure, function, trigger. Right. Cursors. Okay, so when you're writing a method, normally you use for loop to iterate through things, right? So you have list of employees. Now you want to iterate through them, so you will use the for block. So we'll say for first employee up till 10th employee, then iterate. To iterate a record in database, you have to use cursor. Cursors are used only in so for loop. Can you use a for loop outside the method body? Can a for loop be used outside the method? All your logic goes in a method only, right? So all your for loop will be inside the method. We are not talking about static block and other things in general. So your for loop is inside the method. Similarly, the cursor is always in the context of procedure, functions, or triggers. It is not outside those. So cursor, you cannot write cursor in your Java program. You cannot say select star from employee. So say that you write a query, you will say select star from employee. You run that query in your Java program, and then you will say, well, I'll take cursor here. Cursor is always in the context of procedure, functions, and triggers. Right? So cursor is a database side entity. It is not a Java entity. It is a database side entity. In Java side, we will take a result set and then iterate through the result set. So that's the Java implement on the Java side. On database side, when we are implementing procedure, functions, or trigger, if you have to iterate through the records, then you will take cursor and you will iterate you will iterate using the cursor. So cursor is always inside the procedure, functions, and trigger. Okay, this document is pretty slow. Okay, then there's something called as so we've talked about something called as join. Okay, we'll not go to complexity. Yeah, we're not going into the detail. I'll just talk about the definition. We'll discuss it tomorrow because it will be too much for today. So join, as the name suggests, whenever you are joining more than one table. So if you are taking data from more than one table, then you are using database join. Now there are different kind of database joins in different situations. In which situation which join should be taken, that's a separate question. But join in a simple terminology is very simple terminology. You have employee table, you have address table. You want employee along with their addresses, so you have to join the two tables. Whenever you have to join a two table, then you have to use database join. Alright, so we'll summarize the session for today. From tomorrow we will start picking up each, we'll pick from normalization. There'll be another DBA guy. I'll also join in a session to see how it is going. Read through this document for sure today itself. There are only 31 pages. You can read it during the noon, so that the database concepts are very important from interview perspective plus your knowledge perspective. So start reading it about it from today, complete it today, then we'll have the session. The same time work for you, or we can have 7:30 or 8 also. But power should be there. So give me the time where power is there. Mornings. So we can have 7:30 or 8 also, right? 8 o'clock also we can have. So let's do it. 7 is fine. So I'll ask, sure, I'll ask the guy if he's fine for 7 because he works a little bit late. So the guy who is gonna take the session. So if he says 7, then 7. If he says give me one more hour, then we'll have 8. 8 o'clock is also fine for you. I'll message you in any case. But do you think power will be there? Okay. So there'll be a SMS from me confirming the time. Please read through this document. Okay. All right. Sure. Thank you. And we'll again talk tomorrow.